Alright, so we're picking up with number 6. We talked about yesterday horizontal and vertical tangents. Horizontal is when you have dy over dx is equal to what? 0 over number, and then vertical. Right. Say again, Shannon? Right. But with like implicit, they're going to ask you a lot, like, you know, what points do you have, like vertical tangents. So if it's not implicit, then yeah, you're fine. All right, so find the points of any horizontal and vertical tangent lines in the curve by the equation 2x squared plus xy plus 4y squared equals 3. 3. Did that get cut off? Right. Calc humor. Nope. Okay, so derivative of 2x squared gives me 4x plus, when I take the derivative of xy, what do I need to use? Product rule. So derivative of the first times the second, which would be just y, plus derivative of, or the second times the derivative of, no, first times the derivative of the second. Okay. Plus derivative of 4y squared gives me 8y, right, equals 0. Okay. Yes. So derivative of xy is this bracket here, because you have to use product rule. So derivative of the first, which is just 1 times y, plus first times the derivative of the second, which is just dy over dx. Right, because you have an exponent. You don't have an exponent here. Right? All right, so I have 4x plus y plus x dy over dx plus 8y dy over dx is equal to 0. So again, I want to put all my dy over dx terms on one side and everything else on the other. So what does that give me? That gives me dy over dx. You have x plus 8y. And then I have negative 4x minus y. All right, so what I did is I subtracted the 4x and the y over, and then I left the dy over dx terms on this side, and I just factored out dy over dx. So your dy over dx is equal to negative 4x minus y divided by x plus 8y. Not even close. Yep. Okay, so they're asking for horizontal and vertical, right? So horizontal, we have to use the top part. Vertical, we're going to use. So let's do. So we need dy over dx is equal to 0 over non-zero. So I'm going to take what? Negative 4x minus 4 is equal to 0, right? Because that's what we got on the top part. So when you are solving for a horizontal slope, which variables do you think you should be solving for? Y, right? So you have negative 4x is equal to y. All right, so it's asking for the points. All right, so what you're going to do is now use substitution for this piece, and you're going to plug it back into your original. So your original was 2x, right, xy plus 4y squared equals 3. So anywhere you see a y term, you want to replace with negative 4x. I'm sorry, there's not too much I can do. Sorry. Yeah. Now you guys can go and tell all your friends about your calc humor. All right, so again, I replaced any of the y terms with negative 4x. So that's going to give me 2x squared minus 4x squared. So plus 64x squared. I love how everyone just throws you under the bus. It's wrong, Sam. Okay, so if I, very nicely, they are all the same exponents, so I can put them together. So that gives me 62x squared equals 3. So x is going to be what, plus or minus? Right. It is, I swear. I enjoyed it. All right, so horizontal tangent is when you set the numerator to 0. So you set what we found the derivative to be, the top part. We set that equal to 0. And since we are solving for a horizontal line, best option is to solve for y. Plug what you got for y, you plug it back into the original equation, right? And after that, you just do the algebra and solve for x. So you can plug that back into here to get the y term. No. So if x is positive 3 over 62, y is negative 4 times radical 3 over 62. And then if x is, negative radical 3 over 62, y is positive 4 3 over 62. So that's 1 point, and then that is the other. Right. Look at how much room I have. You could be doing it on your iPad. Is that you? We haven't been in church in a while, so got to get it, get it all in. All right, so vertical, you have non-zero over 0. So again, set your denominator of your derivative equal to 0. So now that we're doing vertical, which variable should we be solving for? X. So X is negative 8y. Yes. So, no, you're still using that. Yeah. So to get the horizontal, we use the top part, and to get the vertical, we use the bottom part. Right. Yep. So again, you're going to replace any x terms with negative 8y. So you have 2x squared plus xy. Xy plus 4y squared equals 3. So anywhere I see an x term, I'm going to replace with negative 8y. So I have 2 times negative 8y squared plus negative 8y times y plus 4y squared equals 3. All right, so 2 times negative 8y squared is going to be what? 128y squared minus 8y squared plus 4y squared. So that's going to give me what? 124y squared equals 3. So y is equal to plus or minus 3 over 124. Probably not. If it wasn't, you would probably maybe like try and factor. That might be like possible. So again, to get the x terms, you just have to plug in. So times and then y was radical 3 over 124. So you plug these into negative 8x equals y, right? So that'll give you the x terms. So if I'm plugging in the positive one, it's going to be negative 8 times positive y value that we got. And then the other x value would be when you're plugging in negative. So they're just opposites of each other. Yes? Well, don't do that. I mean, that's my suggestion. Not right, but partial credit. Correct. All right. So these are points where you have horizontal tangents, and then these points are where you have vertical tangents. All right, next one says determine the equation of your tangent line at the point 3, 1. So very nicely we have the point. Now all we need is the slope. All right, so I have d over dx. Okay, so what do I need? What rule am I going to use on the left side? Yes. And then on the right side, you're going to be doing what? Right. Okay. All right, so the left side, chain rule, you have 3 blob squared. So again, you're going to bring down the exponent. So that's going to give me 6 x squared plus y squared to the first power, right? Times now the derivative of the inside, which is what? Very nice. And then are we done with that side? With the left side, though. Yeah. All right, now, derivative of 100x times y. So derivative of the first, right? So you have 100 times y plus 100x dy over dx. Correct. 100 is just a constant, so you can attach it to the x term if you want. Okay, so now you have single term multiplying with 2 terms. So you need to distribute here this term to both of these terms. That would be more difficult. So you're going to have 6x squared plus y squared times 2x. So that's going to give me 12x. X squared plus y squared. Again, you are, wake up. So again, you're taking this term here and you're distributing it to that term, which you get there, plus, again, you multiply this term to that term. Okay. So that's when you multiply 6x squared plus y squared times 2y dy over dx. All right. So we're almost done. So you just put all your non-dy over dx terms to the other side, and you pull over your dy over dx terms to the left side. So that's going to give me dy over dx, and then I have 12y times x squared plus y squared minus 100x equals 100y minus 12x squared. No, I'm sorry, just 12x. X squared plus y squared. So dy over dx is what? 100y minus 12x, x squared plus y squared, divided by 12y, x squared plus y squared, minus 100x. Whew. Almost done. Nope. So it's to evaluate, you need to figure out what the tangent line is. So you need the slope. So you get the slope from this guy. Now what point are we using? Okay, so dy over dx at 3, 1. So anywhere you see a y, you replace with 1. Anywhere you see an x, you replace it with a 3. So you have 100 minus 12 times 3 is 36 times 9 plus 1 over 12 times 9 plus 1 minus 300. That's from the all right, so I have 100 minus 36. 36 times 10 is 360 over 120 minus 300. So what does that give me? That gives me negative 260 over so what does that come out to be? That's oh, you're right, 180. So that's going to give you what? 26 over 18, which is 13 over 9. Right. So your final answer now is y equals 1 plus 13 over 9 times x minus 3. Calc. Yeah. Yes. I'll be the judge of that. This? So this is just Taylor form. So you have y1, x1, and then your slope, which we got. Right. Nope. All right, we will finish this up mañana. Yes.